All right, guys, video number 4. We're going to continue with quadratics, but we're going to do some real world quadratics, mostly about a projectile that goes up and then comes back down to Earth. And so we're going to find the domain and range. Okay, notice what it says in the instructions there. So basically, we're going to do almost all of this in Desmos. You can, of course, find the vertex and all that by hand if you want to, but I'm pretty much just going to be graphing in Desmos. I'm going to sketch a picture of the graph once I put it into Desmos, okay? So number 37 is talking about a baseball that gets hit into the air, and we are using that equation. So definitely that's where this is what we're going to type into Desmos. Now I'm going to change the D to a Y, and I'm going to change the T's into X's. So when I type that into Desmos, right, I'm going to type in Y equals 40x minus 5x squared. Okay, because typically Desmos doesn't like those other variables. So D is the distance from the ground. So of course the ball's going up and then it comes back down. And T is time in seconds, right? How long is the ball in the air? Okay, so I'm just going to hop to Desmos. And I'm going to type that function in so I can kind of see what that looks like. So Y equals 40x minus 5x squared. Now, obviously, parabolas go forever and ever and ever, but for a real world scenario, we only want what's in quadrant 1, right? Because we don't want anything that's going below the x-axis would be like going into the ground, and anything to the left of the y-axis would be like going back in time. So none of that makes any sense. So we only want the part of the parabolic curve that is in quadrant 1. So we want to note a few points here. So it's going through the origin. We also want to note the highest point is that vertex 480. And then we also want to note the other x-intercept when the ball hits the ground. Okay, so I'm noting those 3 points. I'm going to go back to my picture, and you don't have to draw the graph if you don't want to, but I'm going to draw a sketch of what we just looked at on Desmos. Okay, so I'm going to kind of draw my parabola. Lovely. Okay, and so remember that top vertex was 480, which again, you could calculate that by hand if you wanted to using your negative b over 2a. And then this was the 0.80, and then of course 0, 0. And so let me fix that. That looks really weird. There we go. All right, so now we want the domain and the range, right? Well, we know what domain and range are, right? So domain is the x's, and so we're hitting a wall here and here, right? And so we want to look at those x values, right? And so our parabola is only existing from 0 to 8, right? So 0 is less than or equal to x is less than or equal to 8. And if you want to, you could also, put that, right? I'm going to put seconds on the end, right? You don't have to put a label on it, but it just reassures me that I know that x is the time in seconds. So I should be looking at the time range that the ball is in the air. And then, of course, we have our y values, right? Which is the lowest height of the ball all the way up to the highest height of the ball. So this ball is going to exist from 0 all the way up to 80, and that would be meters. All right, so just finding your low to high x and then your low to high y, and there you go, domain and range. All right, the next one, we're basically going to do the exact same thing. So it says April shoots an arrow at a speed of 80 feet per second from a platform 25 feet high. Now, a lot of students freak out when they read all that information. You don't have to do anything with that information. They've already done it for you by putting that 80 and 25 into the formula for upward velocity. So you don't have to do anything, right? You literally just have to type that equation into Desmos and see what's happening. Okay, and again, the H stands for height, but I'm going to change that into a Y. And again, the T, of course, stands for time, but I am going to replace the T's with X's when I put that into Desmos. Okay, so I'm going to go to Desmos. I take that one out, and I'm going to put in Y equals negative 16x squared plus 80x plus 25. Adjust my graph a little bit. And then I want to find all those key points. And again, I only want the ones that exist in quadrant 1, right? In a real world scenario, I don't care about anything else. So I want that y-intercept, which is of course 25, because they told us she was shooting it from a height of 25. I want that vertex up there, which is 2.5, 125. And then I want the other x-intercept, or the x-intercept that I want, which is 5.295, 0. All right, and that's all the points I want. Now I know there's another x-intercept, but he's negative time, and that's not usable, right? We only want the part of the graph that exists on the x-axis, the y-axis, and in quadrant 1 only. Okay, all right, I'm gonna take that with me over here. I'm going to draw a graph. All right, and so our parabola is gonna look like this. That's not going to make a pretty one for me. All right, and so I'm going to label, right? So this was 0, 25. All right, our vertex up here, 2.5, 125. And then our x-intercept was 5.295, 0. There we go. And again, height is feet and time is seconds. So again, we just want that domain and range. So I'm just basically going to do the same thing, right? Domain is furthest left to furthest right, and we're talking about seconds, right? So that means we're talking about 0 to 5.295. So she's shooting that arrow in the air, and so it's going to exist anywhere between 0 seconds, and it's finally going to hit the ground after 5.295 seconds. And then our range is low to high, so floor to ceiling. So that arrow is going to exist at 0 feet, but it's only going to go up to 125 feet, right? And so that's the Y value that we want. So 0 to 125, and that's feet. There you have it. All right, I'm gonna keep rolling along. Number 39, a rock is dropped from a bridge 320 feet above a river. The path the rock takes follows this curve. Again, notice the 320 is just the y-intercept because that's how high above the river you dropped the rock. All right, so I'm gonna go put that into Desmos. All right, y equals negative 16 x squared plus 320. And there's our lovely graph, right? And again, we only want the x-axis, the y-axis, and quadrant 1. Let me fix that a little bit more. There we go. So, of course, our y-intercept is 0, 320, which is also the vertex. If you notice on the graph, that's also the maximum of this curve, right? So our y-intercept and our vertex are one and the same. And then our x is 4.472, 0 for our x-intercept. All right, so that's a pretty easy graph. So I'm going to go over here. All right, so I'm going to plot a little graph. All right, I'm going to chart the path. So it's just going to do this. And so we've got our 0, 320. Let me fix that parenthesis. It kind of looks like a 10. There we go. There we go. And our x-intercept was 4.472, 0. And so that's a pretty easy domain and range, right? Because again, we want low to high. So that's the lowest x. That's not my x's. I'm going to do my x's first. Sorry. So my lowest x is 0. So we're talking about time. So you have the rock at 0 seconds, and then it takes 4.472 seconds, right? So we want to look at those x values. Remember, always least to greatest. These, when you're doing your domain, these should always be less than or equal to, because you should always be writing from least to greatest. And that was seconds again. And then our Y values, right? The rock hits the ground at 0 feet. And it has a maximum height of 320 because that's where you dropped it from, right? So 0 is less than or equal to Y is less than or equal to 320. Oh, goodness. Sorry about that. There we go. All right. Number 40 is asking you to do a quadratic function that matches this table, right? And so that's definitely going to be a regression, right? When they give you a table, right, you're going to be doing a quadratic regression, right? So I'm going to enter all that information in the table. And then remember, we're going to do the regression formula, which is just standard form, but all your x's, oops, I forgot my squared, all your x's and y's have to have the subscript 1, right? So, and then you need this little squiggly for the approximation, right? So y1 is approximately ax squared sub 1 plus bx sub 1 plus c. Okay, and so we're going to type all of that in. Give me 1 second. Let me go grab something. Okay, so I'm going to go to Desmos. All right, we've done this so many times, right? So we're going to go to add a table. So add a table, and then we just want to type all those in. Also, I want to note that at the top of my table, it does say x1, y1, right? You definitely want to make sure that that's happening. All right, so it looks like our x's are going up by 5s. So 5, 10, and it'll catch on to that little pattern here. So I can just hit enter and it'll fill that in for me. And then I'll enter the y's, which are not going to have a pattern, or else I wouldn't need to even do a regression. 64. And 112. I'm just going to double check and make sure, because if there's anything wrong in my table, then my equation's going to be off. Okay, that looks good. All right, and then in line 2, I'm going to type in the regression formula. So y1 approximately, all right, a x sub 1 squared plus bx1 plus c. And as soon as I hit C, all that information should pop up. If that doesn't happen for you, well, then you typed something in wrong, right? If it's not giving you that equation. So I'm just going to make note on my paper here what values it's giving me for A, B, and C. These decimals probably go on forever, so I'm just going to round to like 2 or 3 decimal places. So I'm going to say A is 0.072, B is negative 0.149 if I round, and then 2.732. So I'm just kind of writing those down and making a note so that when I go back to my problem here, then I can write my function, right? So y equals, then I'm just going to put those values in for A, B, and C. 0.072 x squared, right? That's the A, plus, actually minus, sorry about that, minus 0.149 x, and then plus 2.732. Right, so it's just up to you to go in and find, let me just write A, the B, and then your C term from your regression. All right, just throw them in there. All right, number 41, very similar. It's just another table. So I'm gonna go do the same exact thing. So I'm gonna go back to my Desmos. I'm gonna clear all that out so I can add another table. Again, I wanna make sure it says X1, Y1 at the top. Okay, so it looks like our X's are going up by 5s again. So 5, 10, 15, 20, 25, 30, 35. There we go. Oh, these are big numbers. 1353, 2460, 3323, 3940, 4313, 4440 and 4323. Again, kind of giving a look over just to make sure. Looks good. All right, and then I'm going to type in our regression again. So y1 squiggly a x1 squared plus bx. And again, you'll know if you typed it in correctly because it's not gonna, you'll notice it's already kind of giving me an A and a B, but I haven't typed in my C yet. There we go. And you kind of want to go, wow, this guy's got really big numbers. So I'm gonna, right, this looks like a perfect almost, right? So I'm gonna write down my A's, B's, and C's. Again, I'm just gonna round to a convenient spot. So I'm just gonna say negative 4.9. And then B is 294.962. And then C is 0.571. Again, whether you round to 2 or 3 decimals, it doesn't matter to me. Sometimes I just go by what's convenient numerically. All right, so then I can just go back over here and I get my y equals negative 4.9x squared plus 294.962x plus 0.571. And of course, the reason we do this is because what if I wanted to know, after 50 seconds where the projectile was, then I could just plug a 50 in for both of my x's and it would give me a good rough estimate of how high that projectile was at 50 seconds, okay? We didn't ask you to do that on this problem, but. All right, moving on. This question is kind of confusing because of how it asks you to do the work. So here we go. We haven't talked about this a whole lot. I mean, we did when we were star reviewing. It says they want you to write it in 3 different forms. They want you to write it in intercept form. So I'm gonna put a little 1 there. And then they want you to write it in vertex form. Okay, and then they want you to write it in standard form. Let me pick a different color there. All right, so we're gonna have a lot of work on these 3 problems, okay? I'm gonna do the intercept form first. A couple of things that we need to find first though. Before we do anything, we need to find the A value, okay? So the A value is based on the parent function, right? We talked about this before. If you want to, you can also pick some points. If you want to pick, let me find his little reflection buddy. If you want to pick 3 points that you know for sure are on the line and then go run a regression like we were just doing with those tables, you could totally do that, right? There'd be nothing wrong with that. I am going to, remember when we talked about the parent function, y equals x squared, and we talked about his movement from the vertex, right? And we talked about the overs, right? The left-right versus the up-down movement. So basically your x's and y's, right? So for the parent function at the vertex, for the parent function, if I go over 1, then I go up 1 because 1 squared is 1. If I go over 2, then I go up 4 because 2 squared is 4. And of course, 3, 9, et cetera, right? So what I'm gonna do is I'm gonna compare the movement of these guys to the parent function. So if I go find the vertex, right? Do you notice that he's going over 1? These movements will always stay the same, the 1, 2, 3. What we wanna do is figure out what's happening to the y's, right? If I move over 1, am I going up 1? So let's go look. If I go over 1, which puts me here, am I going up 1 and staying on my graph? No. So this does not have an A value of 1 like the parent function does because it doesn't have the same movement. Instead of going over 1, up 1, he's going over 1, up a half. And instead of going over 2, up 4, which would put us there, right? He's going over 2, up 2. Okay, do you see where I'm going with this? And then instead of going over 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is where the parent function would go, or this is where this graph would go if it had an A value of 1. It would be like, whoop, but it's not doing that, right? It's only going over 3, up 4.5. So this is what we need to analyze. Oh, whoopsies. Right, what's happening to my y values, right? They're supposed to be 1, 4, 9, but they're half to 4.5, which is half of the parent function movements. So I know this guy has an a value of 1/2, right? Because I'm only going halfway up the normal, okay? All right, I'm gonna do the same thing on the other graph because we might as well just take care of both of them at once. I'm gonna erase these. Okay, let's go find his a value. So again, it's movement from the vertex. Oh goodness, that's in a weird spot, isn't it? Let's see. And these are going by ones. It looks like it's passing through here. Yuck, that's gross. So if I go over 1 down, it looks like I'm hitting here. So instead of going over 1, down 1, which would put us here, he's going over 1, down 1, 2. And he would go over 2, down 4 if it was the parent function. It's hard because it's on a fractional value, so let's just work on that here. So if I go over 2, 1, 2, he would go down 4, 1, 2, 3, 4, right? But he's not, right? He's going 5, 6, 7, 8, right? When I go over 2, I'm not hitting the curve until I go down 8. Now I'm out of room, so that's okay, but we can analyze what's happening here, right? Do you guys see how the y values are double what the parent function's y value movements are? So that means he has an a value of 2. Now, if this is tricky for you and the movement thing is weird, again, here, let me just show you what I mean by using Desmos. So if I pick this point, and this point, okay? So I'm just gonna make an XY table out of that. This is if you don't understand what I was talking about with the movement, if that was confusing to you. So -1, 0, 0.5, what is that, 4.5? And 2, 0. So just go find 3 points that you're pretty darn sure are on the graph, right? And then I'm gonna go put that in Desmos. All right, so here we go. I'm gonna add a table. This is gonna be nice and quick, right? So -1, 0.5, and 2. And then our values were 0, 4.5, and 0. Okay. Go here. All right, and so notice my little graph. There's my 3 points, and I'm gonna go run a really quick regression. Y is approximately ax1 squared plus bx1 plus c. What did I do wrong? Oh, I didn't put my 1, 1. I was like, what is missing? There we go. I knew something was wrong. And look what it's giving us, right? It's telling you right there that the a value, oh, I forgot to put a negative. Thank goodness I did this. So the a value is -2. And it'll also give you the b and the c, which is awesome. But I'm going to do all that by hand, but you could totally do that, okay? So if you can't find the a value with the movement that I was just talking about, and I totally forgot the negative since it's opening down, then just throw it into Desmos, okay? All right, I'm gonna erase that. All right, now that we know the a values, now I'm gonna start with intercept form. And I did the a value first because you need the a value for every single one of these, so you may as well get it out of the way. All right, so intercept form is exactly what it sounds like. We wanna know the intercepts. Well, this one has an intercept of 2, 0, and 6, 0. All right, so here we go. So y equals, I need the a value in the front. And then do you guys remember when we factor quadratics? I'm gonna write, intercept form means technically factored form. So if my solution is +2, then I know my factor is x minus 2, right? Because it's the opposite number, because we would set that equal to 0 and then solve the equation and we would get x equals 2. Same thing for the 6, that's a positive 6. So in factored form, that would be -6. And that's it. That's intercept form, AKA factored form. Okay. All right, and then vertex form, all you need is the A value, which we already found, and you need the vertex, right? Our vertex is the HK. Let me kind of put a little note here. Let's see, what is that? 4, -2, 4, -2, and that's your HK for vertex form. So remember, I'm going to write it down real quick. AX minus H squared plus K. Again, that's on your formula chart. So Y equals, we already know that A is 1/2, and then we just need to plug in the H and the K. So X minus 4 squared minus 2. And that's it. And then last but not least, we have our standard form, which again, you can totally get from Desmos, but I'm gonna do this one by hand just for the extra practice. Standard form is getting rid of all the parentheses, which means I'm gonna use my vertex form, and I'm gonna actually expand the X minus 4 squared, because that means X minus 4 times itself, and then we're gonna multiply all that out. So you're gonna start with the binomial multiplication, right? So you got to double distribute there. So that's going to give us X squared, right? Because X times X. And then X times -4. But then we have another -4X. So if we combine like terms, we're going to get -8X. And then -4 times -4 is +16. You can also go off to the side and do the box method if you want. And put that in here. So we did the binomial multiplication. Now we need to distribute the 1/2. Don't touch that -2 at the end, right? Subtraction is the last thing, right? And so we have to distribute the 1/2. So we're going to get 1/2 X squared minus 4X plus 8. Then now that we've gotten rid of the parentheses, now we can apply that -2 minus 4X, and of course our like terms, right? +8 minus 2 ends up giving us +6. And there you have it, right? And so those are your, I'm gonna kind of highlight these, right? Right, and there's our 3 different forms of the quadratic. If you wanted to check your answer, you could totally throw all of this into Desmos. You could throw all 3 of those equations in Desmos and see that they all give you the exact same parabola when you graph that. Okay. If you didn't want to multiply out your vertex form to get to here, you could have also multiplied out your intercept form and gotten to there also. Either one would have worked. All right, I'm going to go through and do the same thing with number 43. So again, vertex form, so Y equals, we need the A. Every single one of the forms has to have the A value, which is why I wanted to find it first. And then I just need to go find my intercepts, my x-intercepts. So clearly the first one on the left is -1, which means as a factor, it would be +1, right? Whatever the intercept is, it's gonna be the opposite value in your factored form. And then +2, 0 is gonna give me x minus 2. And that's it, right? It requires no work, right, other than finding the A value. Then on number 2, which is our vertex form, right? We just need that vertex up here. And it looks like that was 1/2, 4.5. And so that's gonna be my HK, and I already know my A value, so I can just hop right to my formula. -2x minus 0.5, or you can write 1/2 squared plus 4.5. All right, and then lastly, we can hop right to number 3. Now, just to change it up, I really don't want to multiply the half and get all the halves and the 0.2. I don't want to do all that. So I'm going to change it up, and now that I have intercept form, I'm going to use my intercept form to get my answer. Now I know obviously we already did this in Desmos, so we could totally do that, but I'm gonna use my vertex form and I'm gonna multiply this out because that looks a lot nicer than having to deal with all those 0.5s. So I'm gonna go ahead and get rid of my two binomials by multiplying them together here because I wanna get rid of all those parentheses. So let's see, x times x is x squared. And then x, that gives me negative 2x plus x, so negative x, and then minus 2. So that's what you get when you multiply your binomials. And then you need to distribute the negative 2. So negative 2x squared plus 2x plus 4. And I'm pretty sure that's exactly what we just got on Desmos, right? When we went over here. Oh, it erased my thingy. Well, I remember that's what it said. I don't want to type all that in again. And there you have it, right? So there's our intercept form, vertex form, and standard form. All right, you guys. Let's do a couple more just really quick. All right, and this is based on the conversation we literally just had, right? It says, given a quadratic equation that has this XY table, what are the factors of the equation? All right, so remember it's asking for factored form. So it's asking for, let me change colors here, right? It basically wants the factored form. Well, if I want the factored form, that means I need to know what the solutions are. Remember, the solutions are your x-intercepts. So you need to go to your table and find your x-intercepts. Well, clearly, that's an x-intercept because it has a y value of 0, and that's an x-intercept. So we're basically doing the exact same thing we just talked about a second ago. I'm just going to draw a little picture here. So it's doing something like this. Well, I thought it was going to give me a nice pretty curve. Really? Okay, I'm going to try one more time and then I'm going to let it go. Okay, so here's my parabola. So it's crossing at -2 and +3. Well, remember in factored form, you're going backwards, right? And you're putting the factors back in. So if my solution is -2, then that means x plus 2 was my factor, right? Because remember, at the end of the day, when you factor something, you're setting it equal to 0. And if I solve this equation, I'm going to get x equals -2, right? So we're just going in reverse. And then if my other solution is +3, well, then that means the factor was x minus 3. Again, because I would be setting it equal to 0 and solving for x, and that's where I get x equals 3. Okay, but it just wanted you to write the two factors down. Oh my goodness, y'all. Sorry, I just wanted to move this over. There we go. I'm just going to write and in between those. There we go. Okay. And then 45, which is our last question for this video, says, what is the relationship between a quadratic equation's factors and its solutions, right? And so you can write a sentence, or you can write something like, if x equals a and x equals b, I'm just going to write if, then x minus a and x minus b are the factors. Okay, basically saying, if that's confusing, if that's too mathy, then you can just say that it's the opposite number. Whatever the solutions are, the opposite number goes in the parentheses as the factors, right, is essentially what that is saying. Okay. All right, guys, I'm going to stop there for our video number 4, and we'll finish up with our very last video here in just a few minutes.